Good morning, and welcome back to another episode. I think, if I remember right, where we got to last time was we've got blending enabled. So now not only can we draw our smiley face, we can also draw like it as a circle, right? We've now got working opaqueness. Whatever the right way to say that is. So if I come in here, Odin run main, we can now draw a smiley face as a circle, which is nice. That's progress. There's obviously still a lot to do. That's not exactly a game yet. I was having a bit of a think earlier off stream, just about what we might do. And I think the first thing that came to mind is I should totally make my build script, build my shaders. I don't know if you watched the last videos, but currently I'm just GLSLCing everything myself. Let's fix that. Let's make that better. And then what else? And then yeah, we want to enable Z depth comparisons, so that we can draw stuff overlapping other stuff. So we will move on from the giddy heights of drawing one smiley face to drawing two smiley faces, to try and make this point, and then work out how we make the thing work. But yeah, then I think after a bit of a sanity check to see if there's anything we want to stop and refactor, I think we're then into starting on building out a game. Right, we need to find some game assets and get started. It's all very exciting. Sorry, I've still got a bit of a cold, so if I'm sniffy and coughy and a bit gross, I'm doing my best. I'm trying very hard not to sniff so much. I've noticed in the other videos I sniff constantly and it's irritating, but you know, if your nose is blocked, I don't know what else I can do. Alright, so let's start with this build script stuff. I think this might all be uncommitted at the minute, so let's just commit readme changes. Right, we've got a run script. It just doesn't build our whatchamacallits. This is in, I guess, the root of our project, right? So if I go, oh, that didn't do what I thought it would. There we go. So this is the root of the Flectris project. You can see the path up here if you're not a Dear user. And then this is like the outputs if you did a LS with a bunch of flags to make it full formed and include hidden files, all that sort of thing. And then this main down here is our Odin package that we're actually using when we do that Odin run main. And what we've then got is a shaders directory, and currently we just spit all of our binary compiled shader code out into the root, which is probably not the best thing to do, but it's not too complicated yet, so I don't think we mind. Alright, where's run gone? So we go back into run. If we come in here and we do glslc-o. In fact, let me just go into here. We'll see in my fuzzy finder. glslc-o vert spv to shaders main.vert and glslc-o frac SPV shaders main.frac. So this may need to get more complicated as things get bigger, but what we're doing is so simple, as long as we're like still looking at this sort of 2D sprite based rendering. I think we actually might get away with literally just having the two shaders. If this got bigger, we could look at doing something where we do something more automatic and do everything in that file or something. But for our purpose, I think that works for us. Do I want to put debug info on them? I think at this point we might want to just make everything debug, right? I'm assuming I can put a dash debug on that as well. So let's try that. And then, in fact, is there a compile available within project? There is a project compile. Okay. So if I go project compile, and instead of doing that, I want to just run sh. Odin run does not take that flag. We pipe that. I don't know why that never seems to do quite what I want it to do. Okay, Odin run. It should take debug. Dash debug. Odin run file name. Do I have to give the path first? That seems strange. If I do Odin run main, it works. If I do Odin run main slash debug, that works. If I do Odin run debug main, it blows up because it expects the package name right after run. Okay, interesting. Didn't know that. So we get rid of you. Oopsie daisy. That didn't do what I wanted. Put you there. Right, let's try that again. Cool, nice. Is it worth just putting a little echo, compiling shaders, and a little echo running main? That seems useful, right? Cool. And then if it does fall over somewhere, we can see if it got through. It should be clear, but the outputs from these can be a bit chunky sometimes. Alright, let's see if I can remember now that thing I have and that I'm going to use, but we tick that off quickly. I think that'll make our life easier moving forward. Unstage changes to you. Just deleted it. That doesn't sound right. Let's run.sh. I hit the wrong button. Embarrassing. Alright, update run script to build shaders. And again, if we get into something where we're doing more complicated stuff and we end up with lots of shaders, the time taken to do that might end up being an issue, but currently it's a trivial part of the compiling time, right? So I don't think we're fussed. I think any cost inherent in rerunning the shader compilation each time will be paid off by the fact that this way I'll never have my shaders out of date as long as I use this script, which has definitely cost me time in the past. Okay. Alright, so now for Z depth comparisons. Oops, bang my mic. Big noob move. Okay, I don't know if it's obvious what that means to everybody. I'm trying to think if there's a good way to explain it. So, obviously what we're currently drawing is trivial, right? We're drawing two triangles to make one quad. Everything's on a flat, single surface. The two triangles don't overlap. So we need to sample our texture and put the value we find into the swap chain image. And that's what we present to the screen. If we add another quad, so if we come into here and we're going to add a second quad, just looking over what we've currently got, we do should I do 0 to 1 in each direction and then they should overlap? So 0, 0. In fact, let's be less dumb. Let's go. Oh god, I'm being more dumb. Let's grab that, copy it, paste it in there. Then can I say grab all of the minus 0.5s and we make them zeros, and grab all these 0.5s and make them ones. Alright, so we have the exact same everything else. So we're passing through the same color, which isn't used anymore. Passing through the same UV coordinates on our simple texture. So what we expect to see is two smiley faces, but obviously they overlap. So that's now not as simple as it used to be. Whoops, my god, I'm rubbish at this. I don't know if it's my Emacs use is paying off. Oh, why did that not work? Ah, our drawers are indexed, and so what we have done is we've made new vertices. We also now need to put in the indices to make that thing exist. So let's just say quad 2. And the numbers will all increment. So instead of 0, 1, 2, we'll have 4, 5, 6. And then that one starts on 2. So it'll go 6. Then it goes back to the start. And 7. Hopefully that will work. No. Why is it missing that triangle? Okay. I am unsure. 4, 5, 6. Now, one of these not right. So 0, 1, 2, 3, 4 gets you to here. Right, because it's 0 indexed. 0, 0 goes to 0, 1, 1, 0, 1, 1. So what we're doing is pause. Ah, we have done it wrong. 7 doesn't exist, does it? Does it? So 4, 5, 6 is easy. And then these should map. So the 2s are in the first and last, and in this first and last. Then 1s, that should be 5, not 4. There we go. Okay. Soon we'll have a program do all that for us, so it's less painful. But you can see, so it works trivially, and they're drawn in the order that they're sort of sent in, if that makes sense. So we've drawn that one second, and it goes on top, and I think if we take this, just to be certain, oopsie daisy, and we come up here, now it should go on the bottom, see? Which is fine for our really simple case. I think it'll get annoying, right? I think that this is basically what I did in the Brackeys project. If is that useful to go and have a look at? I don't know if I left any comments or anything. Useful in here. If I go grep for comments. Okay, there's all these things. Main.odin. I'd be lying if I said I remembered really well how this all works. Oh, there's a lot of comments. Is there anything here about drawing? Draw current game state. Game to drawables. Sounds promising. Left right flipping knowledge assumes player will be the last drawable drawn each frame. Is that the kind of thing I'm talking about? Drawable backing buffer, a total drawable count is equal to player to drawable. Okay, I don't think this is exactly what I was talking about, but I think it's, you can sort of see the point I'm making here, right? Which is that in this game, we want to be able to, in fact, I don't know if I've ever shown this, at least not recently. Oh, the Corby Odin run main. That's running from the wrong place. We do CD to there, and then Odin run main. Main not found. Odin run main from the root. There we go. So we got the little game, and you can bounce around and pick up coins. Right. This is the first little bit of Vulkan sprite rendering I played with. This doesn't do any of this Z buffer stuff. And so you have to handle things like uh, the background blue is one big quad that I've drawn, and I want to make sure that my little guy sits on top of it. I think, hopefully I fixed the collision detection so it's not so bad now. You used to be able to slide the knight into the terrain, and when that happened, imagining that someday you may use this and you want to have like tiles that are like background decoration, you want the knight to walk over the front of them rather than disappearing behind them. And the way you have to do that is you have to kind of carefully look down this and make sure you're drawing things in at the right point. Maybe that ends up being fine. But it does end up meaning things, so like within a particular type, so if you had like enemies, you'd have to make sure the enemies are written into your draw buffer the same way each time, or when they overlap each other. What's an example? Let's say you've got your array full of enemies, and then you do an unordered remove of something from the start, so other stuff gets rearranged, and suddenly an enemy that was drawn behind another enemy now pops and is in front of it, right? Like, that's really annoying and probably hard to track down once it happens. So what I'm hoping to play with this time is something new to me, is the Z buffer. So instead of having to deal with that ordering explicitly by ordering things being sent into draw commands ourselves, what you do is you create a new attachment, which is a depth buffer attachment. It's an image that's the same size as your swap chain image. So there's a value in there for every pixel in your output. And I think this is something that's all plumbed in at a hardware level. It's very fast. So it should have good support through the Vulkan docs. Just skimming them, it looks like that's true. You can set it up so that when it's going to write a pixel value, that's the right way to say this. So you'll have depths associated with each fragment that the fragment shader is operating on. Not even fair. I guess there's a depth associated with each vertex, and a fragment can then interpolate between vertices to find like a depth for each subpart of the triangle in our case. And then when it reads the value from the shader that it wants to put into a particular pixel, it can then look at the depth buffer and see what depth value was last written to that pixel. And if the thing that was there before is in front of the thing that we're currently drawing, we know not to draw it. If the thing that was there before is behind what we're currently drawing, then we know to draw it. And then on drawing, so I say drawing, on writing the pixel value into the swap chain image, it will also write the depth at that pixel into the depth buffer, so that future writes can also do the same check. Which hopefully means that actually this should fit in quite neatly to stuff we've already done a bunch of, right? I think, if I've understood it right, what we need to do is basically make a new image, and then somehow, somewhere, that plumbs into our graphics pipeline. Sorry, I can hear my dehumidifier. I'm down in a basement in true nerd fashion, so I need to go empty the dehumidifier before it gets all humid and gross down here. So expect the time to jump. Okay, and I am back, and I know that'll seem like no time has passed. It's probably quite jarring if you're watching this, but fucking, there's a bit of lore about me. My computers and everything are all set up in a literal windowless basement. So I have to keep a dehumidifier going. If you're not careful with the dehumidifier being on basically all the time you're down here, it very quickly turns into a swamp, and it's just disgusting. So I don't know if you'll be able to hear it beeping in the background, but it was very distracting. Okay, where was I? I think I was waffling about depth buffers. So yeah, that's hopefully a rough idea of what we're doing. If it's not super clear, I don't really know how these bits work. This is all reasonably new to me, so we will work it out as we go. Step 1, though, is we will go and grab the Vulkan spec. And I'm going to do a quick look to see if there's anything in here about depth. They have operations. Is there a... How would I say? I'm not sure how the right way to say this would be. Edit input, vertex input, fragment output. I can't think of what we actually want. You know what we might do? We might go and look up one of these tutorials. So I guess to be clear, with understanding probably no one's watched all the videos. The goal with this was to get away from the Vulkan tutorials. Cause I've gone through a Vulkan tutorial I think at least twice, and tried extending off of one. And what you find, or I found at least, is if they're providing me with the actual literal code I need, it just didn't go in. And I hoped that by extending that Brachy's example off one of the tutorials, that would help make it clear. But you then sort of realize, unless you're making your graphics demands more intense, you don't actually touch a lot of this stuff again. And if you've gone through this tutorial but not really understood it, and then you try to make the graphics demands more intense, well, you're kind of back to a standing start. Like, you don't know what you don't know, so it's very hard to make sort of good progress. So my hope with this is to kind of go through mostly from, I guess, like memory and the spec, and piece it together, right? And we can kind of get something working ourselves. As we put up, I think, like the 20th video to get to the point where we can draw 2 quads. Clearly not a very time-efficient way to make a game, but I do feel like it's making more sense to me. So that's all good. That said, I think one thing I've taken from this is the Vulkan documentation, at least the Vulkan specs, not written in a way that makes it easy to discover stuff. Whether that's the web page or the local PDF. I was hoping using the local PDF would make searches fast, because it's running locally on my machine, rather than having to hop between lots of different pages in a really sharded up like HTML document. That may have been naive, but it's the way I've been working. It lets me keep my bookmarks across things as well, which is nice. So I'm stubbornly sticking to that. I do think there's probably some value in looking up one of these Vulkan docs or Vulkan tutorials around this. So all that stuff I just waffled earlier about how it's an image and how it roughly works is basically stuff I got because I quickly looked up a tutorial last night and read through it quickly. I'm not sure which of these I actually want. So let's try. These are both from the documentation project. 3D geometry. Right. Yeah, this looks like the sort of thing we want. So, this makes sense. We're going to have to add Z values to everything, so that's all good. This might actually be the literal tutorial I worked off before, because I recognise that image. Then it'll make an image and view. Frame buffer is probably what I'm interested in. Render pass, I think we don't do anymore because of dynamic rendering. So there actually might be a bit of working this out ourselves. Depth and stencil state. I look up Vulkan dynamic rendering. Again, there's a nice, bit of their docs where they show the old way and the new way. This is probably it, right? There. Attachments are referenced by a frame buffer, and now they are referenced in rendering attachment info. Do we have one of those? rendering attachment info. We do. Very nice. Where are you used? Can I come up here, search for color, attachment, a bunch of places that have got that, and then it just goes into rendering info. Let me just check, do I have anything unstaged? I do. Oh yeah, it's just me fanning about with vertices and indices. Right, let me pop a to-do comment in here. I've made a shortcut to put in to-dos, and I'm not sure it's the most useful thing in the world yet. So what is this doing here? Add a depth attachment. Presumably there must be a thing in here for depth attachments, right? Easy peasy. Ah, interesting. I thought depth and stencils were normally done in the same attachment. So we're not going to worry about it because I'm not... Oh, why is there not a depth count as well? Alright, we'll look that up in the docs. What was I saying? We're not going to be using a stencil attachment. I had a brief read about it. I didn't really understand what a stencil was. I think it's another thing that you can read and write to that hooks into the kind of fixed function drawing logic, but we don't need it. We're not worried about it. So we need to add a depth attachment into there. But first we need to make our vertices have... Basically, we need to make them 3D, right? We need to make them have Zs on them, which will involve us coming over to wherever vertex is defined, and we now make that 3-dimensional. Everything starts blowing up. Our vertex input binding description has the right size automatically. But we now need to tell it this. Ooh. Is there a problem that they're all 32-bit? I don't think so. Actually, they're probably a good thing they're all 32-bit. It's RGB now, rather than just RG. If we run that, it probably blows up as it should. So let's make this one sit at 0. Let's make this one sit at 0.1. There isn't really any sort of scale to these things yet, is there? So the values are relatively meaningless. In fact, even whether it's bigger or smaller, and what that means is pretty meaningless at the minute as well, because it's not like we've defined like a camera or anything. We're just looking at the image as a 2D image. So I think we're pretty free to define things how we want. Nice. I'm slightly surprised I didn't complain at us from the shaders, to be honest. I thought this would complain. Make you a vec3. Now means that can go. And we go again. And it works. Ah, we didn't recompile the shader though. Can I be better about using my new thing? So we run sh. Cool. Can I break it and make it do something nasty? So yeah, the shaders failed to compile. Ah, interesting. That doesn't stop it though. Is this one of those flags that you see at the top of a lot of bash scripts? Is it I think E, U, and X I tend to see a lot of bash scripts have. Oh. Hang on. Bash script flags. I'm not sure what I ought to say. Flags is the wrong thing. Bash script common set. There we go. Set E. Is that the one that I want? From help set. From here, exit immediately. That's probably what we want to do. So let's dash E like that. It's a bad practice by some. It's recommended to use trap to do something. Okay, you can't make me. So we save you, we rerun, and it catches it. Nice. Out of interest, how does it get it? From help set. Oh, can you just call literally help? No. Let's go see what you're saying. All the flags. What does U do? I think U and X I feel like I see on a lot of stuff. Dash U, treat unset variables and parameters other than special parameters or array variables as an error. An error message will be written to the standard error and a non-interactive shell will exit. And X prints a trace of simple commands for commands, case commands, select commands, and arithmetic for commands and their things. Okay, it's just like a debugging helper. Okay, cool. Actually, U sounds like we probably do want it. We're not doing any of that yet, but that sounds like a good thing to do. So let's set EU. And if I then do echo test in there. Cool. If I take U out, it'll just give me empty, will it? Nice. Look at us learning, improving at stuff. Right, so then that one correctly blows up. We go back to here. We undo that bad change. We run that again. And we're now passing in a Z value. It's not used for anything. So none of our logic has changed. But it is there. That's what I keep doing. What's the thing I'm doing that grabs the whole file? I actually don't know. Okay. What are we doing then? Come back to main? I guess. No, I'm going to go back to renderer. Okay, we're going to have to add something onto our renderer state, which is pretty chunky now. We have swap chain images. We have the view, we have the format. Are we not storing the surface extent anywhere? I kind of expected to see swap chain image extent or something like that. We're going to need to know how big those are. I'm so sure, though, that we do something with that sort of value. What could I regex? Extent? Surface extent? Ah, okay, we do have it. I'm just blind. Can I just say inside of draw frame? I'm just going to print this and check that it updates. It must do, right? Because we're handling window resizing. So if I'm in here, can I just do a format print line renderer dot surface extent and I could put it inside window size callback. That seems like unnecessary faff. Run you. And we can see this spits out absolutely loads of stuff. And if we drag it and we drag it, nice. Yeah, so that is doing what we think it's doing. Can we interrupt it? Kill this. Oh, I think I might be too tired. I keep having like half a thought and then just blanking on what I was going to do. Render a state. We've already got the surface extent available to us. So the thing we need to do is we need to set up our depth buffer. We're going to look in here and just check what we need. So this tutorial is all done in a much more like object-oriented C++ kind of way. So we basically need to know what am I saying? We need to know what they're adding as like fields on their class, I guess. Depth, image, and view. The depth attachment is based on image, just like the color attachment. Difference is swap chain will not automatically create depth images for us. And we only need one because only a single draw operation is running at once. I think this is likely something we're not doing, right? So, are we doing multiple frames in flight? I don't think we are. So that, again, that tutorial introduces multiple frames in flight very early, which is a thing that you would do. So you can start computing the next frame while this frame is still sort of in the works. I don't think we need it. We could tell if we were doing it because all of our synchronization stuff would have to have multiple values. Oh, am I doing it? Semaphores draw finished. What other semaphores do I have? Signal semaphores. Maybe I am doing it. This problem with looking away from a project for so long. Like reading somebody else's code. Okay, create synchronization objects. Okay, we're doing one for each swap chain image. That's not quite the same, right? Probably actually unnecessary. I might stick a little to do in there just to come back and think about that. To do me, what am I thinking? Why are we making a semaphore per swap chain image? I think we only have a single frame in flight. So only need a single semaphore to track. Draw command status. Okay, that's a problem for another day. But what I was going to say is, even if you're doing multiple frames in flight, so you're potentially working on multiple draws at once, you're only ever going to be doing one write to... Oh, is that true? I'm out my depth. In their thing, they are doing multiple frames in flight. I don't see why they couldn't be writing to multiple swap chain images at once. The difference is, sorry, this is the bit I'm reading here. The difference is the swap chain will not automatically create it. We only need a single depth image because only one draw operation is running at once. And the depth image will require our thing. Okay, maybe this is just before they get into multiple frames in flight. I don't know. Feel free to look it up. I'm sure what they're doing makes sense. But we definitely only need one frame in flight. So we need to go and make a image. We need to associate memory with it. We need to make an image view, which we can go ahead and bang in here. You're an image. Feels confusing that we have memory-backed resources of kind of images and buffers, and then your depth buffer is what people tend to call this, but then it's represented as an image. it makes sense that it's represented as an image, because I guess it needs to have the same extent as the swap chain image. That doesn't feel crazy, but I don't know. It just seems a wee bit back to front. What was the other thing? Image view and memory. Image, memory. Let's get up to there. Vulkan dot device memory, I think it's called. Right, so they all now exist, and we need to go and populate them. Can we swap these two around? Just looking at what we've done for the texture image. And then I'm going to go and look for where we use texture image, because we're going to do basically the exact same thing that we do for the texture image. Some of these values are going to be different though. And we don't want to do all of the same things. We're not mapping it, so that's fine. Can we please take all of that and so we'll just plonk it in here. So we're going to say here, create our depth image, and just to sort of reflect what we did above, create depth image view. This is going to be create and allocate depth image. I'm hoping this all translates across relatively easily. Except, of course, it's not because of that. Okay. Okay. We can sort this out. Can you tidy yourself? Create image info. It's create image info. It's going to be 2D. I think the formats all have D in them. So can we please just be 32-bit floats? So it's kind of just the same as the values we're using for everything else. Extent is not this stuff. Extent is Vulkan. Can you be an extent 2D? What's an extent 2D still got depth on it? Okay. The field is 3D, so I guess we just make the depth 1. Width I will make equal to our renderer surface extent dot width, and height will be renderer dot surface extent dot height. Okay. Span that across multiple things. MIP levels 1, array layers 1. I think we care. Initial layout, we don't care. Usage, the depth stuff. The depth stencil attachment. Image create, we create an image. We do not call it a texture image though, we're going to call it depth image. And if image create res failed to create depth image, let's go ahead and say depth image memory, and then it's a new thing, so we can then down here we can set renderer dot depth image memory to be equal to depth image memory. If it succeeds, image create res, create image, failed to create thing. Okay, depth image memory, allocate resource memory for the depth image on the device, physical device. It's device local. I think it's fine. Right, so again, we're not going to access this at all from the host, so it can live in fast memory. And we are going to be referencing it for every pixel we draw, so we care that it's fast. Excellent, excellent. And can we save ourselves a bit of time again? Just come in here, copy all that. Bang it in there. Create info. Create info. Imagery create info. It's 2D. Format is 32-bit float. So again, I think D is just because it's depth. So I guess that it gives drivers freedom to do something different with depth formats than with normal image formats. Image is not the texture image, it's the depth image. All of this is the same except for that. User our depth. Then down here we create the image view. Let's go on the depth image view on our renderer. Fail to create depth image view. Right. Do you compile? Yes. Can I get rid of that printing that I've added? Where did I add it? Was it in draw frame? Not in draw frame. Is it in main? Yeah. Cool. So it's not blowing up, which means we are allocating all of this stuff. And then we've got our to-do down here, which I think is what we need to do now. All right, so we've got a depth image in there. There's probably some stuff to turn it on in our graphics pipeline as well. What does this say? We'll take care of this in the render pass. For completeness, I'll still describe the process for transitioning the depth image. Do we care about this? We might. Okay, let's remember that as a thing. The depth image is currently sat with nothing in it. I'm curious what they mean by they handle it in their render pass. But this is what we want, right? We want to make a depth attachment. We're going to modify this. First specify the attachment description. The hell is all of this? Ugh. I hate reading C++. Okay, let's go back to the docs. Can I have a search for attachment description? So let's see, can we come in here and say attach description? Fragment input attachment interface. When a fragment stage is present in the pipeline, fragment shader subpass inputs from an interface with the input attachments of the current subpass. The fragment shader subpass input variables are matched by input attachment index, yada yada yada. Okay. So what is this? Do I have one of these? Attachment. I haven't got one of these. Should I have one of these? What even are you? Deprecated by that. Okay. So we should not be doing this. No. Okay, let's look at our color attachment, which is somewhere up here. I assume what we're going to want is a depth attachment and rendering. This is the thing it's saying, right? Rendering attachment info is the new way of doing this thing, I think. Come back to the dynamic rendering. Attachments are referenced by the frame buffer. They're now in rendering attachment infos. So we're in here. Our S type is that same thing from above. Our image view is our renderer dot depth image view. Our image layout is right, so currently our image layout is undefined. We probably actually want to say in here, probably want to transition to depth optimal before we get here. Don't know what resolve mode means. Synced bit with a lot of stuff on it. Don't know what load op, store op, and clear value are all going to be. Other than that, we're all over it. So can we search for rendering attachment info? That seems like it's what we actually want. Rendering attachment info. Non-overlapping access between resources for the attachment identified by that image view. Jump to nya. So the rendering attachment info has all this stuff in it. Resolve mode is a value defining how data written to image view will be resolved into resolve image view. Is an image view used to write resolve data at the end of rendering. Okay, so I don't think we care. Resolve image layout. I don't think we care. Load op, value defining load operation for the attachment. Store op, the store operation of the attachment. Let's just use the same as we used before. So when you load the attachment, we clear the values, and if you store the thing... Why are you angry? No completion found. Why no completion found? You get a comment. What's your problem? No, yep, got you. Store op. Don't care, because we're not storing it. What is store op? The store operation. Render pass store operation to find how values written to an attachment during a render pass. Instance are stored to memory. Store operations for attachments with a depth or stencil format execute in this pipeline stage. Store operations for attachments with a color format in that outline stage. Pipeline stage even. The store operation for each sample in an attachment happens after any recorded command which accesses the sample via that attachment or an alias. Because store operations always happen after other accesses in a render pass instance, external synchronization with attachment access in an earlier render pass only needs to synchronize with the store operations, not the operations within the render pass instance. This does not apply. Oh, I don't understand what it's saying. Okay, so VK attachment store op store specifies the contents generated during the render pass and within the render area are written to memory. For attachments with a depth or stencil format, this uses the access type that. Store op don't care specifies the contents within the render area are not needed after rendering and may be discarded. The contents of the attachment will be undefined inside the render area. For attachments with a depth, this uses the access type stencil attachment write bit. Access depth stencil attachment write bit. That just sounds the same as the store op store, doesn't it? I'm a little unsure if that is saying that when it gets to the end of this render pass, it doesn't care? Or is it saying as I write each part within the render pass? If I'm making sense when I say that, I don't know if I am. Specifies the contents within the render area are not accessed by the store operation as long as no values are written to the attachment during the render pass. Okay, values are written to the attachment during the render pass. What does it say? So, VK attachment store op don't care can cause contents generated during previous render passes to be discarded before reaching memory, even if no write to the attachment occurs. I think don't care might work. I'm going to make it store and see though. So let's see. To do mat, can this be don't care? We'll come back and think about it after. Alright, so that gives us our attachments. Where do they pass in? We come up here. Right, let's have a look. Where's color attachment used? In there. You don't have to provide a count of depth attachments because it doesn't make sense to have more than one, I guess. Well, you could have multiple color attachments that you're reading and writing, right? It can't be just that though, right? I think we've explicitly set stuff elsewhere to say that we aren't doing depth comparisons. So I don't expect that to actually be doing anything. If image view is not a null handle, image layout must not be undefined. Yeah. So that was one of our to-dos. Cool. I'm just going to run for a wee. So, expect the time to jump. And again, I am back. What did we do? We've just added our depth attachment to there, but we don't think it's doing anything yet. And when it's run, it complains because, like we flagged, it's currently undefined image layout. So let's assume that we're going to set depth attachment optimal. Get rid of this. And I guess the move is to go look for... Oh, what's the easiest way to do this? How do I just say grep within this file? It's grep. Just grep within this file. I do depth attachment. No, attachment's the wrong word. Depth. Image view. The hell? What am I doing? I don't want to do that. I want to do just grep. And I want to grep for depth image. That found nothing. Oh my god. Let me see. Can I do it as a compile command? Can I just go grep rn depth image view? Save the file. Sure. The fuck? Found nothing? What do I call my thing? Let me go to renderer. Does it mean it's read only? Okay, I think I've hit the wrong buttons in Emacs and fucked it up. Let's go to Flectris and let's go to renderer. Oh, for fuck's sake. If I just undone all the stuff I did. Oh, no. And because I've closed Emacs, it's not even... Well, I can get rid of it. Somehow it's now read-only. Okay. Well, that's annoying. So I assume that means we're going to have to redo a load of that. What a pain. Flectris. Renderer. Oh, fuming. Yeah, all of our stuff's just vanished, hasn't it? There's nothing in here now about depth. Or depth image. Okay. Okay, we're doing it again. We're feeling like idiots. And we're just doing it again. Have we learned anything? Maybe we do it quicker this time. Okay, depth image is there. Depth image memory. I'll have to watch that back and actually pick apart what I did there. That is particularly annoying. Depth image view is a Vulkan image view. Although, on the plus side, I guess my intentions with doing this series of videos, obviously, I hope they're entertaining. I hope people enjoy them and watch them. But we're so early on that, you know, if they get 10 views, I'll be very excited. I was thinking about it. I think the main value I'm getting out of these so far is almost like a bit of a diary, right? To think I can kind of like look back at and be like, oh yeah, I did that. I guess this is part of it. I've picked up a new editor, and every now and then I royally fuck it up. So, hey, we'll try. I will try not to be too salty about it, but I am slightly salty about it. All right, what are we doing? We are ripping off. Christ, this chunk. We don't need all of it, but we're going to need a bunch of it. And that chunk. So, end of paste. Zip, zip, zip back up. There we go. So now instead of that, we're now going to do create depth image resource. We don't need to load anything. We don't need to do any of this transferring. With a buffer, we don't need to allocate it any memory. Don't need any of that. We're in here. Our format, we're doing D32 float. Our width is renderer.surface extent width. Height is renderer.surface extent.height. These things are all fine. Initial layout is undefined, and your usage is going to be as a depth thingy. There we go. Image create result. Create the image, render device, create image, depth image. If we failed, let's create the depth image. You, sir, are depth, and you're new, so you have to do that. You can be device local, that's fine. We get in here and we go renderer dot what depth image memory is equal to depth image memory. And we are going to bother doing all of this because we now know we can't just leave it undefined. Just clocked that I never actually ran this again. We can't do it like that. Come in here and we do a run. Damn it. Undeclared name X. Okay, there's stuff further on that's causing trouble. Okay, let's get into this block and run it. I probably should have compiled it and run it before we jumped back in. I'm just thinking there might be changes that I've made in Vertex and main that now break because renderer's out of date, but we shall work that out pretty quickly, I think. Transfer destination barrier is not us. What are we doing? It's going to be a depth optimal barrier. Can we jump to you? Old layout, new layout. We've assumed it's always color, which is now not the case. So let's say we take an aspect mask, which is a v dot something. What's your type? You're not going to just tell me. Why not? Because it wouldn't compile to that. Yeah, what a pain. Image aspect flag. So you are a v image aspect flag. That should get applied into nya. They call it aspect flag. That will break a bunch of places. One of them being here. So we're going to go from undefined to depth attachment optimal using our depth image, and our flag is depth. We'll fix the other ones in a minute. Command pipeline barrier, source stage top of pipe, dest stage. Oh, we just saw something, didn't we, about when these things have to happen? Store operations for attachments with a depth or stencil format execute in the pipeline stage late fragment tests. Store operations for attachments with color format are in the stage color attachment output. I guess late fragment tests. That's when this needs doing by, so late fragment tests. No dependency flags, image, memory barrier count. That name is now wrong. It is depth optimal barrier. Memory barrier count 0, 0, 0, and 0. We're not doing this. We're not doing that. We're not doing that. Oh, pipeline barrier. We're not doing that either. We end. We submit. We wait for idle. We could group these. We probably should group these eventually. When I say these, I mean our texture image setup and transitions, and our depth image setup and transitions could be grouped, but they should both work essentially, so we're not going to bother. Let's finish the depth image stuff down here just to be done with it. So your 32-bit float, your image is depth image. I don't know what goes in components for that. I'm going to try just leaving it empty. And then sub-resource range, aspect, depth. Attempt. Knew it would blow up. Come in here. And angry. Usefully angry. Because it's missing the flag. The flag is dot color. Recompile. Come in here. And you, sir, are also meant to be using color. In fact, probably better to use this. I can jump like that. Yeah, that does feel better. Dot color. Jump to the next one. Come in here. You. Basically, everything we were doing before is all color attachments, right? And then we can recompile. Okay. Fun. What's this saying? Got a validation error. Image info 0 image view was created with the depth stencil attachment bit, but descriptor type is combined image sampler. Texture combined image sampler. The image view. Have I written the image view to the wrong thing? Can we go look for depth image view, please? Yeah, I've forgotten, haven't I? I'm totally writing. Just do a search for depth image. Can we do a search for depth image? Yeah, that sounds right. Whoops. End of paste. So create depth image view. Images renderer.depth image. Set that to depth, and then we are overwriting our texture image view in there. Silly, silly, silly. And then let's delete that and try again. Draw's fine, no validation errors. It currently isn't doing what we said we wanted it doing though, right? But I still don't think we're doing any depth comparisons. I think we're just, it exists now. But we take that. Should we do a commit? Should we learn our lesson from the last one? Let's commit you and say flags on run script. What have we done in here? Made it 3D. Mine.odin. Make it 3D. Add our depth image stuff. And made it 3D. Cool. So work in progress towards depth buffer. Create depth image resources. And attachment. With pipeline attachment. I can't remember if there was something in here. I mean, shader interfaces sounds possible, right? Just search in here for depth. Does it come up with stuff that sounds useful to us? Lots of detail. Render pass store operations. I'm sure I remember there's a bunch of places in our code where we've had to like explicitly say, and we're not doing any depth comparisons. I'm hoping if I just do a, what's the easiest way to do this? Can I do a compile grep recursive in compile mode format for, I guess, just depth? So we know it's not that. That's us setting up our resources. Extent has a depth on it. Has a depth on it. Creating our resources, creating our image. That's all stuff we've just written. Allocating memory. Renderer.depth image, fatal, depth optimal barrier. Create the depth image view. It's all stuff we've just written. Depth clamp enable. I think we do want to leave false, but it's getting into more interesting stuff. Is there something else in here about depth? Depth bias. Bias enable. I don't know what depth bias means though. Oh, what do we actually do in our draw call? I don't even remember. Oh, we're not in the draw call, we're in the graphics pipeline. Vertex shader stage, fragment shader stage, pipeline shader stages, vertex input state create info, input assembly state, viewport and scissor. Viewport state takes both of them, rasterization state create info, multi-sample state, pipeline layout, descriptor set layout, but I don't think we need a descriptor because it's not directly referred to in our shader. Create the pipeline layout. Rendering create info. Okay, we're currently not passing our depth attachment through, are we? No? What do you have on you? Pipeline create info. Jump to you, sir. You don't take a depth attachment though. The rendering info takes a depth attachment. Interesting. Can we go back, please? Where's our rendering info live then? I'm curious if we actually need to pass that in there then. Does it get done in something else? So pipeline rendering create info. Pipeline rendering create info. Nippy. Pipeline rendering create info does take a depth attachment format. The VK format value defines the format of the depth attachment using this pipeline. Pipeline is created without a render pass. If this thing in the graphics pipeline thing specifies the view mask and format of attachments used for rendering, if this structure is not specified, the pipeline does not include a render pass. Color attachment count, depth format, and this are undefined. If graphics pipeline is created with a valid render pass, parameters of this structure are ignored. Depth attachment format or any element of that is undefined. It indicates that the corresponding attachment is unused within the render pass. Valid formats indicate that an attachment can be used. It is still valid to set the attachment to null when beginning rendering. Okay, so we do need to set that to tell it that we're going to be using this, but it isn't actually our thing, right? Color blend. What do we need to do? We need to go and find our color attachment. Bugger. Can we do search for color attachment? We jump to where you come from. We come in here and we say depth attachment. We did this before, so hopefully we do this really quickly. Rendering attachment. Rendering attach. Oh my god, attachment info with all of this same guff on it. Rendering attachment info. The image view is different though. So it's not the swap chain, it's a depth image view. Image layout is D32, no, depth attachment optimal, because we've just done that transition. Resolve mode is empty, because I don't know what that does. And then we're going to copy the load op and store op and put a to do. Check if that can be don't care. Where is color attachment used? In there, and then this also has a P for depth attachment. And we pass in the depth attachment. And again, we don't have to pass an account because I assume it just is like, I don't know what you want me to do. If you give me all one depth attachment, that means nothing. Right, so it's now present in our what's it pipeline. Come in here and we do our run. It's not broken, but it is hitting validation errors. So depth stencil state is null, but create info's p next rendering create info has a depth attachment format. So I need to look for that. Create graphics pipeline. Pipelines, plural. as a P depth stencil state. There's a color blend state in there. We do P depth stencil state. Be depth state create info. We're going to go to where this is defined. I'm going to bang that bad boy in there. Pipeline depth stencil state create info. Nice. Can we also go find that in the docs? Excellent. Depth test enable, depth right enable, depth compare op. Yeah, this all sounds like what I expected to see. Depth and stencil operations in chapter 30. What is chapter 30? So we can search better. Fragment operations. I should have thought to search for fragment because it happens in the fragment stage. Okay. Never mind. We got there in the end. So as I was saying here, we go one at a time. S-type is trivial, just the normal bookkeeping. Pipeline depth stencil state create info. P next we hope not to need. Flags is always kind of interesting. What values can you have? Rasterization, order, attachment. Okay, all extensions. Hope we don't need them. Depth test enable, whether or not it is turned on. So depth test enable true. Depth right enable controls whether depth rights are enabled when it is true. They are always disabled when it is false. Page to 310. 310? 3010, sorry. Depth attachment rights, if the rights are enabled as specified by set depth right enable or this thing. Oh, okay, we could do it with the dynamic rendering way. Comparison evaluated to true. The depth attachment value ZA is set to the sample's depth value. There is no depth attachment, no value written. Yeah, buddy, we do want that then. So that's depth right enable. Right. If I've understood that correctly, this is the two sides of depth tests, right? So we've got our image, right? Our depth image. The depth test enable says when I'm looking at a fragment to write into my color attachment, do I want to go and look in my depth image and do the comparison and only write to the color attachment if it passes? The depth right enable is saying, and when I've done that right, do I want to go and update the depth attachment with the updated value? I guess you might have something in a more complicated pipeline where maybe you pre-calculate those values or something. But we want both. Depth compare op specifies the comparison operator to use in the depth comparison step. What do we do with you, sir? Always equal. Okay, so it's going to be greater or equal or less or equal. So let me just adjust my mic. I'm shifting around my seat. Depth compare op. So if depth compare op returns true, it does the right. Is that how that works? The depth test compares the depth value ZA in the depth stencil attachment at each sample's frame buffer coordinates. Sample index I. If there is no depth attachment, skips it. Render pass has a fragment density map. I don't know why this just feels like it's going in one eye and out the other. The depth test compares the depth value ZA in the attachment at each sample's frame buffer coordinates X and Y, and sample index I against the sample's depth, ZF. If there is no depth attachment, it's skipped. If the render pass is a fragment density map attachment and the fragment covers multiple pixels, there is an implementation-dependent association of rasterization samples to depth attachment samples within the fragment. All samples in the fragment are covered, and the depth attachment value is updated as a result of this test. All depth attachment samples will be updated. The depth test occurs in 3 stages. Clamping and range adjustment. I don't think we're going to do any clamping or anything, so I think we just ignore this chunk. Depth comparison. If the depth test is not enabled, this step is skipped. The comparison operation performed is determined by the compare op value. If the comparison value is to false, the coverage for the sample is set to 0. Coverage for the sample is set to 0. Oh, why does it have to say it in such like... I understand they're being very precise in what they're saying, but does that mean it gets not written? It sounds like it's not written, right? Oh my god. Okay, I'm going to go with that. I'm going to say that this will write when the value is true. And I think we're going to go with greater. Greater or equal? So what does that say? Is that increasing Z is coming towards us, right? So if I have a Z value of 10 and it's already been written, my depth image at this pixel has a value of 10. I do another write with a value of 20. The depth compare op. I got this right. Depth comparison step. When it compares... Oh, I just need to know which way around it is, though. Why is that so hard to find? I'm going to guess. I'm going to guess for now, and we can flip it if it causes trouble. But so I think what this will say is then... So if I go to write in at 5, it's not greater than or equal to what's already there, so it doesn't get written. If it's 20, it is greater than or equal to what is there, so it does get written. If they're equal, I'm saying it does get written, so we maintain, I guess, the kind of logical feeling that later writes will overwrite earlier writes. Depth compare op, depth bounds testing. I think I'm going to set to false. The depth bound test compares the depth value against a set of depth bounds determined by 2 floating point values with a min and max. Given sample is considered within the bounds if it's in the range. Yeah, so I think we're just going to say that all values are allowed, right? It's just a number. I guess this is probably useful if you have like a render distance. Right, so anything that's past a certain bound, we just drop trivially. Stencil test enable, we're going to turn off. Front and back are stencil op state that I assume we can ignore. And min depth bounds, max depth bounds, I assume we can ignore because we've disabled the thing. What do we get if we run that again? Ooh. Interesting. What does that mean? So our image... So if I remember right, we are drawing the bottom right space first. It is setting on these transparent pixels a depth, right? Which is then making those pixels sit in front of the other one. Because it correctly says, well, they're in front of me, so I shouldn't get drawn. That's painful. I wonder how we deal with that. Maybe Well, so if we can't fix that, we end up back at ordered draws, and this was all a waste of time, which could happen. Is there a way to control when we write? Mm-hmm. Oh, I really don't know. Please don't tell me this is what stencils are used for. Stencil test compares the stencil attachment in the depth stencil attachment at each sample's frame buffer coordinates and sample index against a stencil reference value. If the render pass has yada yada yada, there is an implementation yada 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 yada. If the stencil test is not enabled, or if there's no stencil attachment, it is skipped. If the stencil test is controlled by one of two sets of stencil related state, the front stencil state and the back stencil state, the stencil tests and writes use the back stencil state when processing fragments generated by back-facing polygons, and the front stencil state when processing fragments generated by front-facing polygons. Comparison operation performed is determined by the compare op, the compare mask, and stencil reference. Okay, let me tell you what I'm thinking. So either what we need is something to say, when we update our depth buffer, actually, when we write something that is transparent, and we might define that to mean transparent at all, then actually don't write to the depth buffer. That might be doable. Or I'm wondering if what the right way to do this is to say, actually, we're going to create a stencil attachment and oh, that doesn't feel right either, does it? I wonder if you have enough control over when depth stuff writes. We're looking at this right now. Depth compare op. What other values are available for this? I mean, these are very simple, right? And I assume these are very simple because this is an operation that's optimized on the GPU hardware. So it is literally just like able to do kind of like simple comparisons, and it's checking flags that get set to say, you are bigger than that, or you are less than that. Right, it probably does a subtraction and looks at the sign of what comes out, or something like that. Which means that check can't be sophisticated. I guess to check this is doing what I think it's doing. If I flip the order of my draws, I think it'll look correct again. Right, if we come in here, we take quad 2 and we stick it down there and we rerun. Yeah, so that way looks fine. Oh, what a pain. And that breaks it again. I mean, the way it's behaving totally makes sense, right? But I don't know. I don't know how we deal with that. I guess what it means, it's simple if we literally only handle fully transparent or not fully transparent, right? What we end up saying is, can we say that a value, as we're sampling, actually we just output nothing? That thing we can do, GLSL, fragment shader, output nothing. Do not want to implement a fragment shader. Invoke a fragment shader with no output. Possible to do this layout early fragment shader tests. Might be a good idea to force early fragment tests. Is that a thing we can affect? Been removed for a while. Redefine fragment to include the possibility of it covering multiple pixels. Discard rectangles. Scissor test. Sample mask test. Compares the coverage mask for a fragment with a sample mask defined by this thing. Pointed to an array of sample masks where the array size is based on that. GLSL only has nulls. Okay, I think. What do I think? Maybe this actually just is a hard problem. With the tools available, I don't see a solution easily. Because in the current version of what we're doing, we could just say our texture, which is this hard-coded thing, we know outside of certain bounds that we don't want to draw anything. I assume we could do something like set up a stencil or a mask or something to make that work. Unless we can do something like... Okay, so let me stage that. So this is a working depth comparison, but it breaks our drawing because transparent drawn items still get a height. So one thing we could do is we have a transparent thing. We could have something in our fragment shader. I assume, or maybe something in the vertex shader to set the Z value to something really low. Right, we set kind of like a -inf. So if you're transparent, you're pushed as far back as you can possibly go. And then we have to choose, do we just not support semi-transparent stuff? I think for our simple game works. Right, so we allow windows through things. We don't allow like stained glass looking things. Okay, so that's a working depth comparison, but it breaks our drawing because transparent items still get a height. Let's commit that so we don't lose it. What am I saying? I think if we go to our vertex shader, GL position, Spec 4. So this has the Z on it. I assume the Z that gets used in our depth comparisons is this. So what we can do is we can make a Z to put in there. F32. That recompile, no. That's not how you do things in here. Is it a double? Syntax, unexpected identifier. Yeah, that looks better, doesn't it? Cool. So that blows up. Spurvy capability float 64 was declared. One of the following requirements is required. Oh, should you just be float? Okay. so it breaks. But I set that to 0. So we erase our Z values and we get back to where we started. Okay, yeah, so we can do that. So one thing to say, we can put an if statement in. I know shaders branching with ifs is like a major issue for performance though. So it's preferable, if we can, to not branch and instead do something like only pass through Z. Oh. You know what? I need a wee again, and I think it's stopping me thinking. So I'm gonna I'm gonna pause and come back in a minute, and hopefully it'll make more sense what I'm saying. Right, I'm back. Can I think more clearly now? I don't know. Is there a constant for like minimum float value or something? I want like float max. Infinity can conveniently be achieved by dividing by 0. Maximum representable float is this. Typical maxing float values are this. Okay, so it doesn't look like there is a constant. GLSL, I'll use uint bits to float to get the minimum 0x2f8. Following that, bitcast, this does that. It supports hex floats, so you can write the smallest non-subnormal. What does P do? Is it a power? Try that. Uint bits to float. Can I look that up? GSL. Uint bits to float. On functions. I'm not surprised there isn't just a constant for like min float. Gen type X, gen type Y. Might just being silly. Should I just set it to like minus 10 to the 30 and call it good enough? I do kind of want it to be exact. So uint bits to float turns the encoding passed in parameter X as a floating point number. If the encoding is a floating point infinity is passed in parameter X, the resulting floating point it has an idea of infinity. Can I say in here then? So GLSL inf infinity constant for plus minus infinity. Where is inf is a function. Using infinity saves a lot of logic in my code. There are no predefined constants. However, from OpenGL 4.1 on, your solution is at least guaranteed to work and correctly generate an infinite value. Dividing a non-zero by 0 results in an appropriately signed inf. Both positive and negative zeros are implemented. The correctly signed infinity will be generated, otherwise positive infinity generated. Okay, so I want to do -1 over 0. That's annoying, isn't it? So I want to go float inf is equal to 1.0 over 0. In fact, can I move that up there? That's the same for everybody. But let's have a look, see if I can get GLSL mode. In fact, can I do that if I go install, package install, GLSL There is a GLSL mode. Let's have a look. GLSL mode. Oh, much better. Get out of here, tree sitter. Right, what was I doing? Float. I want to pick what my Z's going to be. If in position dot Z. So if in position Z is 0, if in position Z is 0, then I do want the value. Right, let me just write it as an if and then come back. So we make U like that. The mode wants it all shuffled, so it will shuffle it. Say if in position dot Z, no, dot A equal to 0, so we're fully transparent. No, which way around does it go? I left a note about this. Note. Alpha is 0 means fully transparent. So if it is not fully transparent, then actually Z will be equal to in position dot Z. We just try that and see if it works. So my logic here is if the thing is fully transparent, I set its Z index so it's always the thing right at the back. So it'll only... Oh. Does that even work? Yeah, so it'll always end up overwriting, but then it still comes up order dependent, doesn't it? Okay, let's try it. Angry. Syntax error. Expected one of these. Syntax error. Unexpected void expecting comma or semicolon. Where on line 12. No? Ah. A vector swizzle selection out of range. Oh, because it doesn't know the color. Bugger. Yeah, it's not got an A on it. Because that's attached to the texture. We're not sampling it yet. Ah, fucking damn it. I'm not even sure this solves my problem, does it? Because... Oh no, I guess it does. It's basically saying I'm going to treat the thing... Ugh, what am I saying? If I've already drawn a thing, so let's imagine I've drawn a blue background and it's at depth 0. I then go to draw my smiley face at depth 10, so it's in front of the background. Everything that has an in position alpha that is not 0 gets put right in front, and it will get drawn, which means I don't really support semi-transparency. Everything that's drawn behind doesn't get drawn at all. So if I can go to my fragment shader and update the depth value that gets used, so GLSL update depth from fragment shader. You don't update the depth value in the fragment shader. It's too late at that point, right? So the whole win with the depth fragment, with the depth stuff, is that we're not going to have to touch it in the fragment shader. What should I do in the fragment shader? Don't update the depth value in the fragment shader. The fragment shader can just be this. As long as all of that. In the third pass, both depth textures should be bound to sampler variables. The fragment shader should then compare frag coord.z to the values obtained from those textures. So long as the FBO has a valid depth attachment and you haven't disabled depth rights via GL depth mask, the depth will automatically be written to the depth attachment. Note, you shouldn't bind the depth texture to a sampler. Also, you don't need any color attachments for the first 2 passes. You don't need to enable GL depth test for any pass. In the third pass, both depth textures. Is it possible to modify the depth from the fragment shader? I have a very simple program that renders quads from a top orthogonal view. I'm trying to modify the height of these to simulate spheres and make them intersect other spheres in the scene. Image shows something similar with spheres in Blender. You can set GL frag depth in GLSL. That might be what we want. What are you? GL frag depth establishes a depth value for the current fragment. Fragment language. GL frag depth is an output variable used to establish the depth value for the current fragment. We might be able to do it. And if you don't do anything, it gets set to GL frag coord. I think we might be able to do this then. Right, so every change we've made so far in here is not wanted. Right, we're going to pass through our tech coord and our other thingy. We're going to go to our fragment shader. I'm just going to tell it to format because not got formatting because we've not got a language server. No worries, we'll do that. So our out color is this. I can set GL underscore frag depth to whatever I want to. I'm going to set it to GL frag coord .z. That should give us the same behavior we had before, which it does. And then we say if out color dot a is 0, then GL frag depth equal to minus inf, where inf is going to be something up here, const float inf equals 1/0. Problem. Oh, it doesn't look right around the edges, does it? See that? Why is it doing that? So I guess... Why is it doing that? I guess they must have out colors that aren't exactly fully transparent. Can we do this the other way around? Can we say that is minus infinity, and if out color is 1, so if we say you're fully opaque, then I would like to set it to be equal to out color Flectris.z. Oh yeah, kill that and start again. No. Ah. Okay. What on earth is that doing then? They, interestingly. Okay, so it's fixed our like weird jaggedy edge around the actual edge. I think this must mean that my PNG that I've got has some transparency to it. Oh my god, what's it actually called? Let's go into Flectris. Main smiley PNG. Can I see like individual values in here? Open with open with GIMP. Can I see like individual pixel values or something? See, I can see around the edges. Okay, so that's what we were seeing, right? Is around the edges we've got this kind of anti-aliasing happening. Is there a way to see what your pixel value is, sir? Like a dropper or something. Dropper. Sampled merge. Use merged color value from all positable thingies. Zoom right in. We grab that. Is there a way to see what your RGB is? Lock alpha channel. So let's think about it. We drew this one, then we drew this one. So like here we can see that this has survived. Oh, I'm so confused. What does that mean then? So our white chunk has gotten drawn there. So this white chunk is getting drawn from this one that gets drawn on top, which we expect, which presumably means it is completely transparent. Do something really gross like that. What does that do? Yeah, that reintroduces issues. Just confused about that white line getting drawn. What does that mean? Or about that white line getting drawn overlapping, like it should be. That's correct. We can see from these artifacts that, yeah, this is all from this guy. Why is this shining through, though? Set that to be 0. We get back to the same kind of logic we had before, right? So we default to saying it's sent all the way to the back. And if alpha is greater than 0, we say actually it's the Z color. It's not going to be something really weird about it being an if, is it? So I think the next thing I was going to say is in here. See, I was going to do something like outcolor.a, treat it like it's a binary thing. Okay, I assume that bools in GLSL are 0 and 1. Right? So can I do this in one go? Can I say, if it is 0, I want it to be that number, which I can get doing 1 minus out color dot A plus no, because it's not going to be 1 or 0. So, can I say binary float binary out color A will be out color A not equal to 0. That gives me 0 if it is 0 and 1 if it's not 0, right? I can then say that I want it to be minus inf if binary out color A is 1. Is that right? So out color dot A is greater than 0 is the same as saying binary out color A. So if this value is 1, I want that other one. I think I can do 1 minus this plus out color Z times binary out color A. In this. Oh, sorry, hang on. Yeah, I'm already sending out color. That's my frag depth. Can I convert from temp bool to temp high P float? Okay, I guess bools aren't just numbers in GLSL. GLSL bool to int. To convert a bool into 1 if true or 0 if false, just use the int bool constructor. Love it. Binary out color A. Because I'm being inconsistent in my Americanisms. Damn it. Okay, I think... Let me put a comment in to say... to do work in progress, hacky solution, manually tweak Z buffer value if transparent could support on-off transparency, which is probably enough for what we're doing. Doesn't look right for what we are doing. Doesn't look right with the smiley texture we're using so far. We've been using so far So I think we've found the right stuff to look at if we are going to find a workaround for this. It might be that our texture that we're using is just not a very good one to be using because it's got like intermediate alpha values in it. I thought this binary out color thing would let us kind of get around that by kind of forcing things to act like one or the other, but I guess not. Because again, the part of this that's confusing to me is I don't see how this is getting drawn on top and this is getting drawn from this one from the bottom. Unless these pixels in here have some transparency on them, so they're getting sent to the back behind this one here that was already there. But I'm not really sure off the top of my head how to check that quickly. We could mess around with our image loading code, but I'm hoping I can go find a way to do it in GIMP or some other image GUI app on my computer. If that is the case and that just has some sort of non-trivial alpha values, I guess I'll try again with, maybe I'll even just draw one, right? Make known opaque input textures. And then, well, known opaque except for completely transparent, right? No PNGs that I know don't have any of these intermediate alpha values in them. If we do that, where do we land? We try this, it doesn't work. I think at that point, maybe depth buffering was the wrong thing to do for this. And we just undo all of this and we live with ordered draws. Which, I mean, I guess we'll learn something. I just find it hard to believe that there must be some way to do this where we're manipulating the Z value to make it non-order dependent. But I'm struggling to think of it. So I'll have a bit of a think off video, because I don't think I'm going to be particularly interesting for the next little while. And I guess I'll update with what I find at the start of the next one. So, I don't know if this was successful or not. It was successful in that the depth buffer stuff worked really quickly and easily, right? Like, it's doing, well, it isn't anymore, but it was doing depth buffers stuff correctly. It's just that handling that transparency is then a bit annoying. Okay. I will let you know what I find in the next one. But yeah, if you've made it this far, I hope you enjoyed, and I'll catch you next time.